Alright, and welcome to another tutorial. I'm Dr. Hammond for Intermediate Mechanics Physics 2500. This one I'm going to go over a little bit over the basics of using Python and Spider. So hopefully now you've gone through this first tutorial where it talks about the motivation for using numerical solvers and how I said that I would be using Spider or Python in the Spider environment for programming, which you can easily download from Anaconda as the package manager. And so let's fire up Spider. So as you can see, this is saying that Spider version 4.1.1 is available, but if you look in the top left corner, it says that I'm using Python 3.7 or Spider 3.7. This, I haven't seen any conflicts between version 3 and version 4. 4 is relatively recent. I did see that some files or functions in version 2 that didn't work in version 3 and vice versa. So I'd recommend using at least version 3. That's what I'll be using, but let me know if anything from version 3 doesn't work in version 4 or vice versa, and we can talk about updating. Alright, so here we go. I'll start a new file. And so this is the Spider programming environment, and as I said, it'll be programming Python. It itself doesn't do too much. When you create a new file, it tells you when it is and the author, so whoever this is registered to. What you need to do to run code is you'll need to import packages. So if you try and have, say, like some variable is equal to sign of, some number, and if you are to run this, first it'll ask you to save. And so I've already done this once, so I'll say test2. And you just get a bunch of error messages and it says sign is not defined. So what you need to do is actually tell Python how to get a sign function to work. And so you import the library, so you type import numpy. But when you type in numpy, it would be that every single time you want this sign function that's in the numpy library, you'd have to type numpy.sign. And so people created a shorter way of doing it and say type import numpy as np. And now if you have a will be np.sign. And so that means it's calling the numpy library and it's a function within this numpy library. And now when we run it, you'll see that on the right-hand side you have this variable explorer, and a comes up as some value. That's relatively close to 0 because it's close to pi. And you can see that when you run it, there are no error messages that come up down here. So everything's fine. If you would like to run it without the np dot, you can also do, let's comment that out, and you can say from numpy import sign, and then what we could do is have sign3, and we could just run it this way, and when we run this code, it'll again give you this value of 0.14, and this time you don't have to type this np.sign for everything. However, as far as I know, I think you have to do this for every function that you want. So if you have cosine, tangent, absolute value, all this stuff, you have to list all that. So instead, I just work with np dot sign and all my functions. So we can have b is equal to np.cos3 and c is equal to np.tan of 3, for example. And when we run this, now you can see all these variables popping up on the right-hand side. There's another package or another library that's also useful. Import sci-p as something, call it sc, and we can have d is equal to the SciPy package dot sine of 3, and you can see that A is 0.14 and D is 0.14. They give the exact same value. It turns out that NumPy is a numerical package library for Python, and SciPy is a scientific package library for Python, and so there's a lot of overlap of these two. If you want to find out what other things are in here, you can just type in np dot and then hit tab, and if you hit the tab on the keyboard, then you'll see all these things. The ones in capital letters are some kind of built-in functions, and then the actual like scientific functions that you want to use will come up in small letters. So you have abs, for example, or append if you want to append an array, arc cosine, so the inverse cosine, all these things show up here. And so you can scroll through these things, and these are all the things that are available in NP, and you can also type in the scientific package and see what's also available here. And you can see again that you get a bunch of these functions. So instead of it being called abs, you get like absolute, and but you get again arc cos and arc sine and things like that. So they're fairly complementary. One of the most common things, so I tend to use NumPy instead of SciPy. Also, you'll be wanting to plot your data, and so you'll want to import matplotlib .pyplot as plt, and this will allow us to plot something. So now we don't use that package. So what you'll want to do if you want to plot something is you have to have some variable. So let's call our variable t. That'll be for some time, and so we can run time from say 1 to 10. So we do np.linspace 0 to 10, and then you'll want some number of values. So say 1001 steps in time, and then we'll want to plot this function, and so you can so you don't necessarily need to do this for the first one, but it's good good convention to have that you say plt.figure, and then it'll always pop up in your figure. And you can do plt. Oh yeah, so that's also the thing with matplotlib.pyplot as plt is you just type plt, and that'll be calling whatever you want from that library. So plt.plot allows you to plot that thing. So we can say plot, and then we have say t squared and t and np.sine t. And now we hit F5, and that runs this code, and these figures should pop up. And so we have one that goes as t squared, and we have one that oscillates. And so if you want to zoom in, you can just click on the magnifying glass and zoom in here. If you want to go back to the original size, just hit home. And this one, if you hit the right or the left mouse button, you can move the image around, and if you hit the right mouse button, you can kind of zoom in and out depending on which axis you move your mouse along. So as I mentioned before, I like having my images have separate pop-out windows, and so I find that really useful. Otherwise, they show up, I think, down here or maybe down here. So as I mentioned in here, I like my plots to pop out in a separate window, and so you go to Tools, Preferences. So Tools, Preferences, and then we go to IPython console, and then graphics. And so it's this graphics backend. So you want to change this backend from inline, which would be having this plot inline, to Qt5 or Qt4. So that means that you can have those images pop out and save those separately, things like that. It's kind of more like how MATLAB works. I'm more familiar with MATLAB, so I like things that kind of emulate that. Oh, as I also said, I also like to remove my variables before I run my code. That would be, so say before I had this B and this D, if I didn't remove my variables and then I ran this code, these things would still be in memory, and so they would still be showing up here. And then later on, if I forgot that I had taken them out, I might say have something like D times A, and it would still give me a number, but I want that to not work because that's not how my program works anymore. So as I say, I go to, I like having a clear all command. So you can do this in the Spider environment itself. So you go to Tool Preferences again. And then when you click on Run, left column, General Settings, remove all variables before execution, and that allows you to make sure that all those variables are cleared. I like setting that up. Those are kind of the basic things that I like changing from the defaults. All right, and I think that's basically it. I think you probably have used Python in Physics 1500 that from Symmetry to Chaos course. So hopefully you have a version installed and are a little bit familiar with it. I'll be uploading code for things that I want to work on and then be kind of walking you through those codes. So the next tutorial will be going through some example codes.